How to optimize inference latency for large language models. Optimizing inference latency is a bit like tuning a long road trip. You start by profiling, which is simply spotting where the slowdowns happen, the same way you check for bends or traffic before a journey. Then you move into infrastructure, where smart hardware choices and tight batching give the model a smoother lane to run on. After that comes model tuning, where quantization or pruning makes the model lighter, almost like removing unnecessary luggage so the engine can breathe. And finally, you reach deployment, where low latency runtimes and caching keep the entire system responsive even during rush hour. Interviewers love when you explain latency this way, because it shows you see the problem as a full pipeline, not a single trick. Once this layered view clicks, optimization stops feeling mysterious and starts feeling manageable. Quick answer: multi-level optimization strategy. A simple way to think about optimization is to imagine 4 dials you can turn. The model level dial focuses on shrinking and simplifying the model through quantization, pruning, or distillation, so it moves with less resistance. The infrastructure dial is about using the right GPUs in batching, so each request rides efficiently rather than traveling alone. The architecture dial tunes attention flow and KV cache habits, so the model avoids repeating work it already knows. And the deployment dial ties everything together with load balancing and fast serving systems that keep responses steady under real traffic. Interviewers often look for this multi-level mindset because it shows you can diagnose bottlenecks from several angles instead of guessing in the dark. It's one of the clearest signals of production maturity. Key optimization techniques explained. Picture the optimization toolbox laid out in front of you. Quantization reduces precision, so the model becomes faster and lighter, almost like switching from steel parts to carbon fiber. Distillation trains a smaller model to copy a bigger one, letting you keep the skill while trimming the weight. KV caching saves previous keys and values, so the model doesn't reread its entire history, the way you'd keep helpful notes in a margin instead of rereading the whole chapter. Batching groups requests together, so the GPU processes them like a smooth conveyor belt instead of one item at a time. And speculative decoding lets a small helper model guess the next steps while the large model verifies, which feels like having an assistant who drafts before you approve. Together, these techniques create real speedups, and interviewers often ask which one you'd choose when latency spikes unexpectedly. Production LLM pipeline stages. A helpful way to understand the full pipeline is to imagine a relay race. Data ingestion starts the run. Pre-processing cleans and shapes the baton. Model loading brings your runner into position, and the inference engine carries the final sprint toward the finish line. Optimization fits naturally into each stage. Quantization and batching often deliver 3 to 5 times speedup. Smart hardware and caching approaches can cut operational costs dramatically. And with enough tuning, achieving under 100 milliseconds becomes realistic for real-time products. Interviewers love when you explain the pipeline as a sequence of cooperating stages, because it shows that you think like an engineer who understands systems, not just single components. This perspective is often what separates a good candidate from an exceptional one. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find it. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.